One of the questions in your practical was, what is the percentage concentration of 10 milligram per milliliter solution? Yep, you've done that question? Right. Now, I'll show you a few tricks for that. Well, first of all, let's remind ourselves, what does percentage actually mean? Well, percentage means 1 in 100, and we said a 1% solution that is equivalent to 1 gram per 100 milliliter. Is that right? Yeah? That was our definition. So if we have 1 gram per 100 milliliter, then this is a 1% solution. And this weight per volume, don't worry too much about that, because that just indicates that we are talking about weight per volume, gram per milliliter. We can have occasionally solutions that are 1% volume per volume. That is quite frequently when you mix a cocktail. Because that means you've got, say, 10 milliliter of, say, vodka in 100 milliliter of cocktail. And you see, here we have volume per volume. Yeah? So that would be a 10% vodka solution. Okay, we have 1 gram per 100 milliliter, 1%. Now, our starting solution is 10 milligram per milliliter. How do we get this into this format here, into this per 100 milliliter? Well, we just simply multiply the top and the bottom with 100. And why does that help us? Well, it helps us because we now have 10 milligrams per milliliter times 100 and times 100 here. Then we have 10 milligrams times 100 divided by 100 milliliter. And this 100 milliliter, that is already one part of our percentage solution. Remember? We said per 100 milliliter. Yeah? So all we need to do is we need to calculate what is 10 milligram times 100. What's that? Loud? 1,000 milligrams. Thank you. 1,000 milligrams per 100 milliliter, or 1 gram per 100 milliliter. So in this case, it is a 1 gram per 100 milliliter solution. In percentage. It's a 1% solution. So 1 gram per 100 milliliter equals 1% weight per volume, gram per milliliter. So the first question really was, a 10 milligram per milliliter solution is nothing else but a 1% solution. That make sense? No? Okay. Okay, let's see. I have a 0.2% solution, weight per volume. How many grams do I have in 100 milliliter? Sounds very healthy. How many grams do I have in 100 milliliter? Do you want to discuss that with your mates around you? How do you address this? Well, we know definition of percent is 1 gram per 100 milliliter equals 1%. But I have a 0.2% solution. So I have 0.2%. I don't have a 1%, I have a 0.2%. So instead of 1 gram, I have only 0.2 grams per 100 milliliter. So 0.2%, I have 0.2 grams per 100 milliliter. Yeah? Does that make sense? What would happen if I had a 3 milligram per milliliter solution? What is the percentage of that? Sorry? 10%? 3%? 3%? 0.3? We are only out by a factor of 10, which is not a bad thing. So who is right? You want to change 0.3? 3%, 0.3, 0.3, any other numbers? 0.3? What about 33%? No? No? How do we get that? Well, we don't want to know what it is per milliliter. We want to know actually how much it is per 100 milliliter. Because that is our definition here, 100 milliliter. So it's completely irrelevant what it is per milliliter. We want to know what it's per 100 milliliter. So all we need to do is extend this fraction, top and bottom, by 100. So then we have 100 milliliter down here, and that goes back to our definition here. Per per 100 milliliter. And what do we have on top? We have 3 milligrams times 100 divided by 100 milliliters. So the bottom is already okay. We don't need to worry about that. And the top we just have to calculate. So that would be, that would be 300 milligrams. So it would be 300 milligrams, or I can write this also as 0.3 grams per 100 milliliter. Okay? Does that make a little bit more sense? A little bit practice, you'll be there. What was another question that people had took offense? Let me see. If that would work. For heaven's sake. Aha. Ooh. Now let's have a look at this one. This is one of the C1V1. And it says, what volume do we need? Volume is required of 250 micromolar solution, of a 250 micromolar, and this is called a stock solution. So this is the stock. It's like when you cook, you have a chicken stock or you have a, God knows what stock, fish stock or something. This is the stock. This is the concentrated stuff. To make 10 milliliters of 25 micromolar solution. It's not exactly the question that you have done in the practical, because I want you to think about the question that you did. I don't want to give you all the answers. There wouldn't be any point in that, because you want to learn that yourself. But it's close enough. So, what are we going to do here? And my advice is, whenever you come across, say, practical manual or something like that, do a little sketch, do a little drawing, so that you see what is going on. So, what we have is, we have a pot with our stock. So that's the stock. That's the concentrated stuff. And now we make up a new solution . That is our diluted solution. And we take a little bit of the stock and put that into water or whatever, buffer or things like that. That is what we do. And you've all done that. When you mix a drink, you take a little bit of this stock of, God knows what, concentrated orange juice or so. These Robinsons stuff you can't drink neat. It makes your hair curl and flips up your toenails. It's really disgusting, but if you dilute it, you take a little bit of that stock, put that into, say, 9 parts of water, and then you have your diluted solution. Yeah? So this would be the diluted solution. And this is basically exactly what you do. You dilute your stock. Now you've learned this from the practical. You've learned this C1V1 equals C2V2, right? Nobody knows exactly what C1 and V1 and C2 and V2 is, and I could tell you that, but usually, very often, people just simply forget. This is one of the other equations that I'm never really comfortable with. Because what am I looking for? And how do I calculate these things? I like to think in a completely different way. And here I show you the shortcut. So, just let me write this on a new page. We want 10 milliliter of a 25 micromolar solution. That is what we want. We have a 250 micromolar solution. That is our stock. And here comes the trick, here comes the magic. Have you ever been to a pharmacy? Yeah? Have you ever been to a GP who gave you a prescription? Yeah? What does it say on the prescription? It usually says this patient needs this drug in this concentration and that much. So, a poorly guy goes into the pharmacy. That should be a snake. It's a pharmacy sign. And says, here is my prescription, and it reads, I want 10 milliliters of a 250 micromolar solution. This is what it says on the prescription. That is what the doctor has written down. And here's the pharmacist. Here's the pharmacist. And they say, oh, I'm so terribly sorry. We don't have this concentration. Oh, sorry, I made a mistake. This is 25 micromolar. Yeah, sorry if I confused you. Nobody said anything. So I want 10 milliliter, 25 micromolar. The pharmacist says, I'm so sorry. We don't have 25 micromolar. We only have 250 micromolar. What can we do? Actually, the answer is already there. Do you see how I've written that? That here is the counter. That is the recipe or prescription, and that is what's available. So it is 10 milliliter times 25 divided by 250 micromolar. And that gives me the volume that I need. Sorry? Why? No, it's just, yeah. It is the same as the C1V1 equals C2V2. V2. But if you just think of it, I want times I want divided by we have gives you the volume of what you need. In this case, 10 milliliter times 25 micromolar. Let me write that nice. 10 milliliter times 25 micromolar divided by 250 micromolar. I see the micromolars cancels out. And all I have left is the unit milliliter. And that's exactly the volume that the unit for the volume. So I've got 250 milliliter divided by 250. So I want 1 milliliter of my solution. And that's the answer. Now let's have a quick look at your question, if I find it. Again. We have a stock of 200 micromolar stock of 200 micromolar, and we want 5 milliliter of, what was it, 25 micromolar. Is that right? From the practical? Yeah? Was that right? Yes? 5 milliliter of a 25 micromolar solution. Now you don't even have to think about what you're doing. What is it that I want? What is on my prescription? Give that guy 5 milliliter of a 25 micromolar solution. Yeah? But the pharmacist says, sorry, we only have a 200 micromolar solution. Micromolar and micromolar cancels out. And I have 5 times 25, that is 125, is that right? Milliliter divided by 200. And that is 0.625 milliliter. So, coming back to our little model that we had. Here's our stock. And the stock was 200 micromolar. And here is our solution. We have 5 milliliter of our diluted solution. And we take 0.625 milliliter of that and put it in here. Put it in this one here. And if we do that, then we get a total of 5 milliliter of a 25 micromolar solution, if we do that. So we put in 0.625 milliliter in our pot, and we add water and buffer. How much? Loud? We add water or buffer, whatever it says, so that it makes up 5 milliliter. So we take 0.625 milliliter plus, and together we get 5 milliliter. How much water? 4.375 milliliter water. And we have a total volume of 5 milliliter. And in this case, it has exactly the right concentration what we wanted. I have a stock solution of 285 millimolar, and I want to make up 10 milliliter of a 50 millimolar solution. How would you do it? So we want 10 milliliter of a 50 millimolar solution. That's what the prescription says. But we only have 285 millimolar. We see the millimolar cancels out. So we've got 10 milliliter times 50 divided by 285. That's 500 divided by 285. And that gives, wait a moment, equals 1.745 milliliter. Yeah? 7? 5.4. You see, me calculating that in my head, it's not a good thing. 1.754 milliliter. So I need, yeah, you got that? Yeah? Everybody got that? More or less? Pat, the person sitting next to you on the back. That, you know, in a way that is bonding. No, I said bonding, not bondage. You get me into trouble since I'm recording that. Right? So I need 1.7 0.54 milliliter of stock. How much water do I need? How much water do I need? 8.246 milliliter of water. Is that right? Yeah? Are you happy with that? I don't want to say it's piss easy. Recording that. But if you have this, I want, we have in mind, you can do your final year project. Already, yes, you can do it. Because that is one of the things that quite a number of students, even in their final year, really struggle with. And then weird and wonderful things come out. Now, when you take always the units with you, like I do, and some people call me a unit freak, but if you take your units with you, then you, by default, have a very good idea whether your result is correct. So, for example, if we do something like that, stock a 1 molar solution, and I want 10 milliliter of 10 millimolar solution. How much do I need? Okay, over to you again. How many milliliters? Now, the horrible thing in this case was I have given you a molar, but I want a millimolar. So we can still write our we want. So I want 10 milliliter of a 10 millimolar solution. Yeah? And we have only a 1 molar solution. Now, unfortunately, I can't just simply cancel out the capital M, because I still have a milli here. I can do two things, however. I could convert the 1 molar into millimolar, couldn't I? How many millis are in 1,000? So 1 molar would be, how many millimolar? It would be 1,000 millimolar. And now you see, I can cancel the millimolar against the millimolar. So what do I have left? I have 10 milliliter times 10 divided by 1,000. Gives me 0.1 milliliter of stock. Yeah? How much water do I need? I want a total of 10, so in this case I want 9.9 milliliter of water or buffer. Okay? Happy with that? You can do it? Absolutely simples. It might help if I press the record button. First of all, what is our new volume? 5. Why? 3 add 2. So we've got 5 milliliter. That's our total volume now. Yeah? Now we need to calculate what our concentration is. Can you remind me what is the definition of concentration? Loud? It's the amount of moles per volume. So, moles per volume. Do we know the amount of moles that we put in? Not yet, but we can calculate it, can't we? So, the first question is, how many moles come from this side here? So how many moles are in 3 milliliter of a 10 millimolar solution? So how many moles are in 3 milliliter of a 10 millimolar solution? Can we do that? So, how many moles in 3 milliliter of 10 millimolar solution? What is the unit that we are looking for? Moles. Do we have anything where moles are in? Where the unit mole is in? Yeah, where? Oops. 10. So we've got 10 times 10 to the minus 3 mole per liter. Yeah? So we've got the mole up here already. We've got the unit mole, that's exactly what we want. Yee-hoo! But we need to get rid of the liter. Do we have anything that with which we can cancel out the liter? 3. Dictate, what do I need to write? 3 times 10 to the minus 3 liter. Liter cancels out. So all I have left is 10 times 10 to the minus 3 mole times 3 times 10 to the minus 3. Yeah? And I can put that together. So 10 times 3 gives me 30. And 10 to the minus 3 times 10 to the minus 3, that's 10 to the minus 6. 10 to the minus 6 mole. So 30 times 10 to the minus 6 mole are in these 3 milliliters. So from this side here, I put in 30 times 10 to the minus 6 mole. That's on that side. Yeah? Does it make sense? Now, can I calculate the same thing for these 2 milliliter and the 20 millimolar? Can you quickly do that with this dimensional analysis? What do you get? Or shall we do it together? Nah, you can do it. What do you get? 2 milliliter of 20 millimolar. How many moles is that? Got it? Got it? Yeah? How many moles? 40. You are absolutely right. It's 40 times 10 to the minus 6 mole. Yeah? So now we have in our pot 30 times 10 to the minus 6 mole and 40 times 10 to the minus 6 mole. How many moles do we have? Thank you. 70 times 10 to the minus 6 mole. That's our total amount of moles that is in this pot. And what did we say? What was our volume? We said we have 70 times 10 to the minus 6 mole in 5 milliliter. Or I can write the 5 milliliters as 5 times 10 to the minus 3 liter, can't I? Milli. Convert that. So I have 70 times 10 to the minus 6 mole in 5 times 10 to the minus 3 liter. Do you note what I've got here? Mole per liter, what is that? How can I write this? With a capital M, that's my concentration. And can somebody do this, please? Okay, it is 1.4 times 10 to the minus 8. I doubt that. Sorry. Anyone else? Okay, not that that I really doubt you, but what was it? 0.014. And the unit? Molar. So have you seen the trick, how it works? You have to get the moles together if you mix the solutions and then divide by the total volume. Does that make sense? Can you do the questions? Go in peace.